Hey class, this is Mr. Wind here with a video on 16.3, interpreting vertex form and standard form. Now last lesson we learned about vertex form a little bit. Remember, it's called vertex form because it's very easy to figure out what the vertex is from that equation. And standard form is actually something that we've looked at before for polynomials in general, but we're going to look at it for quadratics. But before we get into any of that, this first part is just going to help us identify quadratic functions based on the graph. So for a quadratic function, it's always going to have to be a parabola. Right? If it's a parabola, it's a quadratic function. If it's not a parabola, it's not a quadratic function. So let's just look at these. Let's look at this graph. This is not a parabola. This is a straight line. So this one's going to be not. Is not a quadratic function. Okay, this one over here, is this a parabola? Does it curve down and up or up and down? This is. So this is a quadratic function. Okay. This one, does it look like a parabola? Well, it goes up on one side, but it never goes back up on the other side. It stays flat. This one is not a quadratic function. It's actually an exponential function. Alright, let's look at this one. Is that a parabola? Yes, it is. This one is a quadratic function. Okay, let's look at this one. Is that a parabola? And yes, it is. Because even though it's upside down, that's still a parabola. That's like you throw a basketball in the air and it comes back down. This one is a quadratic function. Okay. And let's look at this one. Is this one a parabola? Well, it goes off to the side like this, but it never curves back. So this one is not a quadratic function because it's not a parabola. Now, if we're given something in standard form, a polynomial in standard form, remember that a function is quadratic if it can be represented like this. So that's a polynomial with degree 2. And this would be standard form if it has the squared term. Now, the axis of symmetry for a quadratic equation can be found just using those letters. So if you have it in standard form with that a, and b, and c values, the axis of symmetry can actually be found using a formula like this. It's going to be the line x equals negative b over 2a, where b and a come from that standard form. And also, you can actually find the vertex from the standard form. It just takes a little bit of calculating. Negative b over 2a is going to be your x value, and then f of negative b over 2a is your y value. In other words, first find your x value, negative b over 2a, then plug in that x value into your function or into your equation to get your y value. So we'll do a few examples of that. So part A here, let's look at this one. Negative 2x plus 20, we want to figure out if it's quadratic. Well, this one's not going to be quadratic because my a value is 0. In other words, it's missing this whole x squared term. It has to have an x squared to be quadratic. Alright, it's okay if it misses these other terms because it's still degree 2. But if it's missing the x squared term, it's no longer quadratic. Alright, part B, y plus 3x squared equals negative 4. Let's see if we can rewrite this in this form. So standard form with all the degrees, the degrees of the terms in decreasing order. So right now I got y plus 3x squared equals negative 4. Well, I can just use some algebra if I want to get y equals on one side. So I'm going to just subtract both sides by negative 3x squared to get rid of that. And I want to put the x squared term first, so I'm actually going to put negative 3x squared here. Minus 4. Alright, now we got a polynomial in standard form. We're going to compare this to this form. Sorry, y equals that. And we want to know if it's a quadratic function. Well, it has the x squared term, so basically, yes, we're good. It is a quadratic function. Now, if this is a quadratic function, we're going to give the axis of symmetry. Okay, just look up here on the notes. the axis of symmetry is given by negative b divided by 2a. So we need to identify what is our a, b, and c values. So again, we have y equals negative 3x squared minus 4. Okay, well my a value, let me erase some of this, we got too much going on here. My a value is my coefficient of the x squared term. Okay, I have an x squared term here, so my coefficient is negative 3, so a is negative 3. My b value is my coefficient of the x term. Okay, well I actually don't have any x term here, so we're going to say my b value is actually 0. In other words, I could rewrite this standard form as negative 3x squared plus 0x minus 4. So I'm just adding 0 here. That shows that my b value is 0. Lastly, my c value is the constant term. In other words, it's the term without any x. So negative 4 is going to be my c value. So now I want to find the axis of symmetry. Our equation says it's got to be negative b over 2a, or really the line x equals negative b over 2a. So my b value, we said it's 0. My a value is negative 3. And let's see what's happening here. Um, 0 divided by anything is actually just 0. Right? So if you have 0 slices of pizza and you try to split it up amongst like 6 people, each person's going to get nothing because you didn't have any pizza to start with. So 0 divided by anything is 0. So my axis of symmetry is x equals 0. Okay, my vertex, let's check what it says for vertex. It says negative b over 2a is actually also your x value. We got negative b over 2a is 0, so 0 is my x value. For my y value, I need to plug in this x value into my equation. Okay, so my equation is negative 3x squared minus 4. I'm going to plug in this x value for x to figure out what the y value is of that vertex. So I plug that in. 3, so that's 0, equals 0 minus 4, so just negative 4. 0, negative 4 should be my vertex. So again, axis of symmetry and the vertex, just refer here. It'll tell you what you need to know. Remember, your axis of symmetry goes through your vertex, so if you know one, you know the other. So like you have a parabola like this. Here's my vertex. Well, your axis of symmetry cuts through the vertex. So that makes sense that your x value of the vertex is the same thing as the line of the x equals your axis of symmetry. But it's nice to have it memorized. I do believe it's on your star reference sheet though. Okay, and again, standard form, we have decreasing. So we have your x squared term, your x term, and then the term without the x. Okay. Alright, do these practice problems 6 and 7, that's going to be good. Alright, next section, we're going to change vertex form to standard form. Remember, vertex form looks like this. We can easily find the vertex from it. It's just your h and your k. H and k is the vertex. And we want to change it to standard form. So all we got to do to do that is basically just solve or use some algebra to expand things out to change it. So over here I'm starting with a. First, just order of operations. I want to do exponents first, or parentheses first. X minus 6 squared. Okay, if you remember, that's x minus 6 times x minus 6. You can do the FOIL method, F-O-I-L, first, outer, inner, last. Or you can just distribute and distribute again, same thing. Or notice, this is a perfect square trinomial. We have a formula for that. A squared plus 2ab plus b squared. If I have a plus b all squared. There's also a version with a negative. A minus b squared equals a squared minus 2ab minus b squared. You can use any of those methods to expand that x minus 6 squared, but I think foiling is the easiest to remember. So if you do that, you get that part inside the parentheses there. Now the squared is gone because we just expanded it. Then they distributed this negative 4 to each term in the parentheses. Okay, and they got that plus 3. They went ahead and added that 3 to that 144 combined like term, so 147. Now this is standard form because we have the x squared term, then the x term, then the term without the x. Okay, and that's all it takes to change from vertex form to standard form. So again, it tells you all the instructions here. Expand the squared term, then distribute or multiply that other term into your terms inside of the parentheses, then simplify the constant -1 with whatever term is there, and then you'll get your answer. Okay? So make sure to do that. That's very good practice that you need to do. Numbers 9 and 10 are good to do as well. Alright, section 3. We want to write a quadratic function given a table of values. So here we're given this table. To write a function, it's easiest to find the vertex first. So the vertex is where your minimum or maximum value is. Okay, so notice on the y's we got 9, 1, 0, 1, 9. This goes from 1 to 0 to 1. That's a dead giveaway that here's my vertex, because my parabola is going to look like this. Here my y value is 9. Here it's 1. Here it's 0. Well, that's the point where it turns around. So my vertex is -3, 0. And that means h and k is -3 and 0 respectively. I can plug that into my equation like they did here. They plugged in h there, they plugged in k there. So they got a times x plus 3 squared. Now just like we did in 16.1 actually, they took another point from our table. So let's see, they took the -2. So let's take this point, -2, 1. They plug in, they have this equation right now. Then they plug in the x value for your x, -2. And they plug in the y value is 1 for 1. And then solved for a. Thankfully here, a is just a very easy value, it's just 1. Okay, so again, we found the vertex, plugged it in as h and k into our vertex form, and then solved for a. So the vertex form is, they plugged in just a is 1 here, so that you get that one. And if you want to change that to standard form, do the same process as before. Just expand this and change it until you have separate terms, x squared term, x term, and then just your c value. Okay. Alright, part B is good practice. You should do that as well. Alright, 12 and 13 are good. Section 4, we want to write a quadratic function given a graph. This is going to be almost the same as a table as we just did. Again, step number 1, find your vertex. Here's my vertex, 0, 25. That's my h and my k. I plug in my h and my k right there. Step 2, take another point on the graph, like 1, 9. Plug that in for your x and your y. In this case, it's actually t and f of t, but same concept, input, output, x, y, t, f of t, same thing. So my t value is 1, I plug it in there. The y value is 9, plugged it in there. Solve for a, you got your a value. Plug that back into your vertex form, and you get your answer. Sorry, vertex form they had over here. They plugged in a was -16. So you can take time to read through that, see how they did it, work on those practice problems. Part B is good. Okay, 16, 17 are great as well. Alright. I went through this one pretty fast, but hopefully you learned something. Have a good one, and think win-win.